Getting information from graphs. This lesson is pretty involved, and it also will require the use of a graphing calculator. So if you want to grab your graphing calculator and be ready to use that. First, let's look at the graph of this function f of x. You can look at it and see that it passes through the point 2, -3. Since the graph is a function, we can also name this point in the form f of -2 equals 3. This is another way to write points if they're part of a function. The number inside parentheses is always the x, and what it equals is always the y. So some other points of the graph are 0, 1, 1, 4, and 3, 0. And we could write those in function form: f of 0 equals 1, f of 1 equals 4, f of 3 equals 0. So sometimes you see points represented that way rather than the traditional in the parentheses x comma y. Now, if we wanted to find all of the values for which f of x equals 2, that means we want to find every time y is 2, what are the x's that go with it? So where y is 2, I see 3 points. 1, 2, 3. The values of x every time y is 2 would be -1, and then it looks like that middle point is about at 1/2, and then at +2. We might be asked to find all the values for f of x greater than 2. So that would be all of the values above the line here where y is 2. Now there's lots of them. It doesn't have to be just the dots that you can see dots drawn. Every part of those line segments is above where y is 2. So we're going to write those as intervals from left to right, where the x's start and where they stop. So the top segment, or the farthest left segment, would be right here. And it starts when x is at -4, and it stops when x is at -1. Now -4 is solid, and it's above where y is 2. So we're going to put a bracket on that. The -1, however, is right where right where y equals 2. We don't have an equal to on our greater than. So because of that, we put a parentheses on the -1. Then the next little bit that's above where y is 2 is this little triangle. From left to right, it starts when x is 1/2. But again, it's right on where y is 2. And since we don't have the equal to, we have to do a parentheses. It goes up and then back down, and it ends where x is 2. And it's right where y is 2 again, parentheses. Since both of these intervals are part of the answer, we'll put a U for union in the middle. Now let's talk about domain and range. Domain is all of the x values from the farthest left x to the farthest right x. So looking at this graph as a whole, we're not looking just above 2 anymore. The entire graph as a whole. The farthest left this graph goes is when x is -4. And it's solid there, so we'll put a bracket. The farthest right this graph goes is when x is +4. Right here. And so it's solid there, so that also requires a bracket. The range will be all of the y values, from the lowest y value to the highest y value. The lowest y value, this lowest point, The y value is -2, and it's solid there, so we put a bracket. The highest y value will be this point right up here, and y is 5 there, and it's solid, so a bracket. So domain is the farthest left x to the farthest right x. The range is the lowest y to the highest y. So part A, we're to find h of -2, h of 0, h of 2, and h of 3. All of those numbers are inside the parentheses, so that means those are the x values, and we need to find the y's that go with them. H of -2, I need to look where x is -2 and find the y value that goes with it, which is right here. And that's where y is +1. H of 0, when x is 0, y is down here at -1. H of 2, when x is 2, y is up here, 1, 2, 3, right here at 3. And h of 3, when x is 3, y is 4. Part B, find the domain and range. Domain is the farthest left x to the farthest right x. The farthest left my graph goes is when x is -3, and it's solid there. The farthest right my graph goes is when x is 4. For the range, lowest y value to highest y value. The lowest my graph ever goes is when y is -1. The highest my graph ever goes is when y is 4. Part C, find all the values of x for which h of x is 3. So we're looking for all the places where the graph crosses y at 3. Okay, I'm going to draw a blue line at 3. So every time it hits the blue line, I need that x value. So it happens when x is at -3. It happens when x is at 2. And then it happens one more time when x is at 4. Part D, find the values of x for which h of x is less than or equal to 3. So it's below the blue line. And so it starts when x is -3. We have the equal to this time, so we have a bracket. So when x is -3, continue to the right, we're still below the blue line, still below the blue line, until x is 2. And then it hits the blue line. And then we have one more, just a single dot, when y is less than or equal to 3, and that's at the point 3, 4. So x equals 4 would be another value when y is less than or equal to 3. And then we're not going to do part E. We can also use a graphing calculator to draw a graph and then determine the domain and range. So we want to do the domain and range for the graph f of x equals x minus 1. And into the y equals of the calculator, we're going to type in x minus 1. And you can use Zoom 6 or hit graph, and you can see what the graph looks like. So keep in mind that forever to the left is -infinity, forever to the right is positive, down is -infinity, up is positive. Let's look at the domain and range. The domain is the farthest left x to the farthest right x. Well, this is a line, so it's going to go forever to the left. Forever to the left is -infinity, and it also goes forever to the right, which is +infinity. Always parentheses on infinity. When a graph goes from -infinity to +infinity, you could also write the symbol for all real numbers, which is this capital R with kind of a double line on the left side there. So either answer is fine for that. Then the range. Range is the lowest y value to the highest y value. It starts from down, you look from lower to higher. So it's going down forever to begin with, and then it goes up forever. So it's also all real numbers for the range. Looking at the graph 4 minus x squared, we're going to graph that on the calculator again. Plug that into the y equals. However, this one's a little bit different because they've given us a restriction. -1 is less than or equal to x is less than or equal to 3. And so normally when you look at this parabola and you think about the domain and range, it goes forever to the left and forever to the right. But we're not allowed to go forever left and right. We have to stick in between -1 and +3. So we're being blocked off. Here's where x is -1. And then here's where x is 3. So we can only look at the section in between those red lines. The domain then, the farthest left it goes, x value is -1. Because we have the equal to, on the less than or equal to, it's going to be a bracket. And then the farthest right x value is +3. Now the range, we have to go from low to high. So the lowest y value right here, and you could zoom in and count that, the lowest y value is when y is -5. And the highest y value would be at the very top of the parabola when y is 4. Now there are more exact ways to find those points besides zooming in, but the problems you have for your homework will work that you can just zoom in and find those for now. Now next we're going to look at where graphs are increasing and decreasing. And when a graph is increasing, that means when we're looking from left to right, it's going uphill. When the graph is decreasing, as we look from left to right, we're going downhill. And the answer will always be x values, never y values. So let's look at this little graph of the parabola. And you can see first, as you move from left to right, it's going uphill, so it's increasing. And then after the top of the hill, it goes down again. So from what x values is it increasing and what x values is it decreasing? Increasing from left to right, it's coming from the left forever, which is -infinity. And always parentheses on infinity. It continues increasing and until it gets to the top of the hill, where x is -3. It's solid there, so you'll want to put a bracket. Then it starts decreasing from the time it's -3 until forever to the right. Be careful. The graph is pointing down, and we think of down as -infinity, but that's a y value. We're only doing x values left and right. So since it's going to the right forever, then that's going to be +infinity. Different books sometimes only use all parentheses on increasing and decreasing because you could argue at the top of the hill that point is neither increasing nor decreasing, so it shouldn't be included with a bracket. So I'll take either way on that. This problem is a textbook problem that asks you to find about increasing and decreasing. So if we look at this graph, at first it's going uphill, increasing, then downhill, and then uphill again. And remember, we only give x values. So it starts increasing at that dot. It's not forever to the left because it doesn't go forever. It has a definite start at the dot at -1, 2. So the x value is -1, and it keeps going uphill until it hits +1. Then it starts going downhill from the time x is +1 until x is 2. Then we're uphill again from the time x is 2 until x is 4. You can see from these graphs that the change between increasing and decreasing occurs at the tops of hills and at the bottoms of valleys. The tops of hills are called local maximums, or just maximums, and the bottoms of valleys are called local minimums, or just minimums. Since maximums and minimums are measurements of height, they are y values. So if we look at this graph and we want to find all the maximums and minimums, and then we also want to find the increasing and decreasing levels. The maximum is the top of this hill, and that point is 0, 2. Now, maximums are y values. So the way you would write that answer is maximum of y equals 2 at x equals 0. Then there are two minimums. One right here, that point is at -2, -1. And then one here, that point is at 2, 0. So you would write minimum of y equals -1 at x equals 2. And the second one would be y equals 0. Or x equals -2 for that first one. Then the second one, y equals 0 at x equals 2. Then the increasing and decreasing, you want to only list x values. So the graph goes down, then up, then down, then up. So it starts with decreasing, and that graph comes from forever to the left, and it goes downhill until it hits where x is -2. Then it increases from the time x is -2 until the time x is 0. Decreases again from 0 to 2, and then increases from the time x is 2 until forever to the right. Now, we could look at the graph and tell the maximums and minimum values because they were integer values. They weren't decimals, they weren't partway in between 2 points. But when that happens, you have to use a graph accurate answer. So we're going to do the graph of g of x equals x to the 4th minus 2x cubed minus 11x squared. And when I plug that into the y equals and graph it and do the standard window, some calculators might say zoom standard instead of zoom 6. Then it looks like part of the graph is chopped off. Down here at the bottom, we can't see everything. So we need to change the window. And anytime your window needs to be changed on your calculator, I'll tell you what to change it to. But when you push window, then you're going to change the values like you see here to this window. The x minimum is -5, x maximum +5, x scale of 1. Y minimum, we need to go down lower to see everything, so I made that -100. Y maximum 25, and Y scale 10. Anything under Y scale you don't ever have to worry about. Now in homework instructions, I usually give windows in a more abbreviated form rather than to write out all of that window stuff. So you can see how the x's go from -5 to 5 with a scale of 1. The y's go from -100 to 25 with a scale of 10. Now when we push graph, now we can see everything. And we can see where the maximums and minimums are. If you have the iPhone app, all you have to do is touch the maximums and minimums, and if they turn red, you've touched the right spot and it will give you the maximums and minimums and you are done. If you do not have the iPhone app, if you have the real calculator or you have an Android, then you're going to have to go through the steps that I'm going to describe here. So you're going to push second, trace, and choose number 4. We're going to find the maximum first. So number 4 is maximum. Second, trace number 4, and it's going to ask you for a left bound. So you just move the cursor somewhere to the left of that highest point and hit enter. Then it will ask you for a right bound, so you'll move the cursor somewhere to the right of that highest point and hit enter. And then anytime it says guess, you just hit enter. So we end up with the final screen. It gives us the maximum and minimum. Just the maximum, sorry. And notice the E in the answer. When you see an E like that on the calculator, that is a scientific notation. So, for example, for the X, what that really means is negative 3.045 times 10 to the minus 7. Well, if you move the decimal point 7 places to the left and fill all that in with zeros, that number is basically 0. Same thing for the y. Negative 1.02 times 10 to the negative 12. Moving the decimal 12 places to the left and filling that in with zeros, the y is basically 0 also. Now, write the answer with the y first. Maximum of y equals 0 at x equals 0. So we found the maximum. Now we have to find the two minimums. So this time you'll push second trace 3 for minimum. And the first screen is of the farthest left minimum. And they'll ask you to go to the left. They'll ask you to go to the right and then guess. And so there's the minimum. And we will write that minimum of y equals negative 13.61 at x equals negative 1.71. We'll just round to 2 places. Then you'll do second trace 3 again for the minimum on the right side. And when it says left bound, you go to the left, hit enter. Right bound, go to the right and hit enter. Hit enter when it says guess. And then we have a minimum of y equals negative 73.32 at x equals 3.21. Now suppose we also want to know the increasing and decreasing intervals for this graph. I think it's easier when you're doing that to draw the graph on paper and label the points where you had the maximums and minimums. So I recreated the graph, and we just need x values for increasing and decreasing. So I gave the x value of the minimum, x value of the maximum, x value of the minimum. And you can see it goes down, up, down, up. So we'll write first it's decreasing from negative infinity until negative 1.71. Then it's increasing from negative 1.71 to 0, decreasing again from 0 to 3.21, and finally it increases from 3.21 until forever to the right.